Hello everyone, welcome to today's YouTube video on finding the area of a circle x, y and z. So we want to find the area of this circle, this part x, y and z. So we have that this side is equal to this side, which is 3. So what we can do is to bisect this angle, which is 90 degrees, into 2. If we bisect it, we will have a line running through the circle and tangential and meeting this tangent at this point, so that here is 90 degrees and here is 90 degrees. So this length now is equal to r, radius of the circle, and this length also is equal to r, radius of a circle. So we can draw a line parallel to this, dropping it to this point, tangent to this point. We have under r. We can drop it this way also. We can draw another line this way parallel to this r. So we have that type of figure. So we will set out to find this line, this length. We will find this length. We know from here to here, know from here to here. That's, we will find them too, but this is r, this is r, but we don't know what this is. So let's call here P. So let's now start. So from this configuration, area of the right angle isosceles triangle is triangle ABC is equal to half base times height, and that is 9/2. That is the area of this stuff. Area of this circle, let me call here D. Area of this circle, and call here L, call here K. You can say area of circle DLK if you like. Area of circle DLK is equal to pi r squared. Question 1, pi r squared. We can also find the area of this square. You know, this is r is equal to here, is equal to here, is equal to here. So it's a square. Area of square, let me write it this way, square CL clock. It will look later. CLOK. Area of CLOK is equal to r squared. That's the length times breadth. So we call it equation 2. That means that our area of a quadrant, our quadrant is now this. So let me call it log. Area of LKO if you like. Area of LKO, area of LKO. Area of LKO is equal to pi r squared over 4, because it's a quadrant, and you know, it's drawn this way. Area of a quadrant, LKO, is equal to that. Therefore area of Z, area of Z, therefore area of Z is equal to area of the square minus area of the quadrant. Area of the square minus area of the quadrant. And area of the square is this, equation 2, r squared. And area of the quadrant is this one, pi r squared over 4. So Z, area of Z is equal to r squared into 1 minus pi over 4. R squared into 1 minus pi over 4. So that is the area of dz. So when we find what r is, we can easily substitute and get it. So we can call this one equation 3 and call this one equation 4 if you like. So we now go to the area of the whole stuff that will give us the area of a triangle. So area of this plus this plus this plus this will give us the area of the triangle. So area of areas x plus y plus Z plus the circle will give us area of triangle ABC. So that's what it will give us. So, but area of triangle ABC, we have found it before to be 9/2. So we will now use that. So, but since here is equal to this place, it means that this area is equal to this area, because this bisects this line into two. These places are equal. So we now have that x, this guy is equal to x. It's equal to x. So we now have that 2x plus z plus area of a circle. That circle DLK is pi r squared is equal to 9/2. So that's what we will have, and we know now that z is equal to r squared into 1 minus pi over 4 plus pi r squared is equal to 9/2. Then let me just factorize this. 1 minus pi minus pi over 4 is 3 pi over 4, and it's equal to plus x plus 2x is equal to 9/2. It's equal to 9/2. So this whole thing here is equal to this, plus 2x is equal to 9/2. So that means that this implies that 2x is equal to 9/2 minus r squared into 1 minus 3 pi over 4. 3 pi over 4. Okay, so that is what our 2x is. That is what our 2x is. So we can easily find what x will be. X will be half of it. You can easily find it and find what x will be. So okay, so but the next thing we will have to do is to find this length. If we find this length, we know that this length will be equal to this length, especially when this place is divided, the angle is divided into 2. It will divide this into 2. So if we want to find here, we use the Pythagoras theorem. Using Pythagoras theorem. Using it, we find that AC squared plus BC squared, AC squared plus BC squared is equal to AB squared. AB squared is equal to AB squared. AC squared plus BC squared is equal to the hypotenuse squared. So that means that our hypotenuse here is equal to AB is equal to square root of 3 squared plus 3 squared. That is 3√2, because this is 3 squared, if you like. So that is our AB. That means that if here is 3√2, half of it is 3√2/2. So here is 3√2/2. This side is 3√2/2. So that is what we have. That means that this length is equal to this length, because this guy has been bisected into half. Here is 1.5. Here is 1.5. From here to here, 1.5. So what we now have is that first of all, in order to get the length CP, because we don't know it, we can use this to find the diagonal. We can also use Pythagoras theorem and say that CO squared is equal to r squared plus r squared. CO squared is this line, r squared plus r squared, for that right angle triangle. This implies that CO is equal to 2, if you like, r. Okay, let me just do the working. Equals to r squared plus r squared is 2r squared root 2. That's what we have. So you have r root 2. That's what you have, r root 2. But this CO is equal to CP plus PO. CP plus PO. PO is R. So CP, that is where we are looking for. CP is equal to r root 2 minus R. That's what will give us the CP, the length of the part that we don't know. So since we are now found here now, we have now found it to be r root 2 minus R, and we know here we will add them and equate. So we add, therefore, r root 2 minus R plus R plus R. This is the green segment, this is the red segment, and this one is the blue segment. So the green is R, this one is R, this one is R root 2 minus R root 2. So this one will cancel this one, and you have is equal to R root 2 plus R root 2 plus R is equal to 3 root 2 over 2. 3 root 2 over 2. That's what that one will give you. So you now see that this one is 1.5 root 2. That means that our R, if you factor R out, you have root 2 plus 1 is equal to 1.5 root 2. It's equal to 1.5 root 2. So that means that this implies that R is equal to 1.5 root 2 over root 2 plus 1. Root 2 plus 1. And it will give us that R is equal to 0. If we use calculator, 0.879. So that is what we will have that to be. So we can now substitute this R into our area for circle. Therefore, the area of circle DLK, the one in green in our figure, is equal to pi r squared, which is equal to pi into, and pi is 3.142 if you like, squared, and you have it to be equal to 2.43 square units. Okay, that's for the circle. For x, area x is equal to, so what we will now do is to use this equation, or this equation. So we'll now say that is 9 over 2 minus r squared here is 0.879 squared into 1 minus 3 pi over 4. You get the answer. Also, we get 2x. We get 2x to be precise. That's what you get for 2x. So that x will be half of that. X will be half of this, which is 9 over 4 minus 9 over 4. Okay, 9 over 2, 1 over 2, 1 over 2 of the whole thing, 0.879 squared, 1 minus 3 pi over 4. That's what you get. So you do the math and you get the answer. Square units. So also we have found that for z we use this formula. and we put it there. We'll have that is equal to 0.879 squared into 1 minus pi over 4. Pi over 4 is also 3.142. So you find these are the answer. We just do the math and get the answer. Thanks, and please subscribe. Please subscribe and click on the notification button so that whenever we post new videos you see it and enjoy with us. Bye.